So in this video, we're going to talk about parametric equations in 3 dimensions. And so what we're going to look at first, we got an example here to start out with that says make a table of values for this parametric equation. And so in 3 dimensions, we don't have x, y anymore. We have x, y, and z. So what we're going to do is come up with a bunch of points given the time parameter. And those points are all going to have an x, y, and z value. So what we're going to do is start out by plugging in -2 into each equation. So it's going to be 2, I don't want to use green here, let's use white. 2 plus 3 times -2. And 2 plus 3 times -2 would give us -4. And I can't use white in there. There we go. Okay, and then let's plug in -2 here. We get 1 minus -2. And 1 minus -2 is, excuse me, wrong box. This is in the y value. So that would be 3. All right, back to this. 4 plus 2 times -2. Well, 2 times -2 is -4. And 4 plus -4 is 0. So we've got our first ordered triple in 3 dimensions. It would be -4, 3, 0. All right, so let's go back and plug in -1. I'm just going to erase the -2 and put -1 in there. There we go, -1, -1. And so 2 plus 3 times -1 would be -1. Well, there we go. And then 1 minus -1 would be 2. And then 4 plus 2 times -1 would be 2 as well. And so one thing that you might start noticing here is a pattern. From -4 to -1, it goes up by 3. From 3 to 2 goes down by 1. And from 0 to 2 goes up by 2. And those numbers should kind of stand out over here. They are the coefficients of the t, which kind of acts like our slope, the way slope behaves in, slope-intercept form. So that's how the x's, y's, and z's are going to change. So rather than plugging each number in, I know that this is going to increase by 3 each time. So -1 plus 3 is 2. And 2 plus 3 is 5. And 5 plus 3 is 8. And then the y values are going to go down by 1 each time. So we've got 3, 2, 1, 0, -1. And then the z's are going to increase by 2 each time. So it's going to be 4, 6, and 8. So we came up with 5 points for this parametric equation. And when you graph these 5 points, that's going to be this parametric equation represented in 3 dimensions. So let's go the other way then. Let's say I give you 2 points, and you need to come up with a parametric equation that uses those 2 points. So it's kind of like working backward from what we had. So let's just start by pretending we've got these 2 points. I'll just call this one A and this one B. And we're going to graph point A here, and that is 4, -2, 3. And then point B is somewhere over here, and that is -1, 0, 5. And we have this line that connects A and B. And there's a bunch of different points on this line, but 2 of the points that we know are A and B. So what we can do is kind of like how we ended off that last problem. We can look at what's happening from the x's. So the x's are changing from A to B. They're going down by 5. So the change in x is down 5. The change in y, and the way I got down 5 was from 4 to -1. That's a decrease of 5. And then from the change in y from -2 to 0, that's going up by 2. And then the change in z from 3 to 5, that's also going up by 2. And so for our parametric equations, we can write x of t, that'll be our x part of our parametric equation, that is decreasing by 5 each time we increase the time by 1. And then what we can do is we can say, well, we started with 4, so we're just going to do +4, because each time it's going to be subtracting 5 is you're going to start out with subtracting 5 from 4, then you're going to subtract another 5, and then another 5, and another 5 to get the next set of points. So for the y parameter, excuse me, the y part of the parametric equation, we are going up by 2, so it's going to be 2t. And then we started out at negative 2. And then for the z part, it's going up by 2, and we started out at 3. So one thing that's kind of commonly known with parametric equations, if you're given a couple points or 2 or 3 points, and you come up with parametric equations, these are not unique. There are many different ways of writing this. In fact, I could have, instead of using the numbers out here that I use, let me highlight them in green, I could have used the -1, 0, and 5 because it's going to keep continuing that way as well. So there's many different ways of writing this, especially if you know multiple different points on this line. But anyway, that's our parametric equation. Oops, wrong one, sorry. Let's go back. There we go. That is our parametric equation.